Kris Efland, VP of Engineering of Deepgram. Hello, welcome. And Kris, can you tell us a little bit about your company?
Sure. So Deepgram is the leading provider of foundational models for voice AI. We wrote the original patents on deep learning with audio, and we power most of the voice AI platforms out there, from everything from Twilio to Salesforce to Salesforce Agentforce, which they launched last week, all the way through to like Vappy, Anthropic. All the voice stacks are built on top of Deepgram's models.
Amazing. And so let's start with the basics. The first question I have for you here is, what's the core innovation behind Deepgram's speech AI models that allows them to handle such a wide range of accents and dialects and noisy environments with high accuracy?
Yeah, so that's a great question. We process more audio than Google. It's about, kind of 2 billion or so words a day kind of thing. But a lot of it has to do with our in-house training. We have our own in-house labelers. We have our own in-house language team, our own in-house data curation. And we have the earliest voice foundation models on the market. And so we've been at this problem for almost a decade. And so a lot of the innovation we've come at and we've delivered, a lot of it has to do with the fact that we've been doing this for so long, right? So, the folks that are just kind of coming on the scene, they're, a few years behind us in terms of encountering some of the problems that you see. So you'll see some of the other solutions when you start to ask it to read off a phone number. It might start yodeling, or it can't get an alphanumeric right.
Yeah.
It can't pronounce an address. And so, we have a ridiculous amount of data that we've trained on.
Yeah. I forget which company this was, but one of the issues they kind of ran into was that some countries will pronounce things like 333 instead of saying 333, and their models weren't trained to catch that. Yeah.
It'll actually transcribe the word triple and then three.
And then it just messes up the data.
And then you have to repeat it if you're in a voice agent context. It's got to come back and repeat it, and they're like, well, this isn't really that much better than talking to a human.
Right, and at that point, the person doesn't know that they have to change the way that they say it, right? Instead of 333.
But they shouldn't have to. But they shouldn't have to, right? And that's really the difference. I think that the talk I just got done giving is really highlighting the fact that human behavior starts to come in when you're talking to these things, because the expectation is, especially for someone who's not even aware that they're talking to a voice agent, might have some high expectations in terms of what they're expecting. They expect it's a human. They expect it not to interrupt. They expect it to know when I'm done talking, right? Whereas if I talk slow, or I'm reading off maybe my credit card number or my account ID, if it's not trained properly, it doesn't understand context, doesn't understand turn detection, right? Then the whole thing breaks apart, right? The model will come in and it'll barge in, it'll interrupt you, then you have to repeat what you just said, and then it may not transcribe it right. So it just ends up being super frustrating.
Yeah, and I'd love to double click on that, because voice is such a rich signal of information. So beyond transcription, how is Deepgram using audio intelligence to sentiment or topic detection to help organizations extract meaningful insights from conversations? You were kind of giving me an example there of slowing down your speech. So do you have that programmed in there?
Yeah. So you can check it out today, flux.deepgram.com. That's one of our latest models. It's the world's first conversational speech recognition model. It delivers unprecedented speed and accuracy, leveraging Nova 3, but it's a whole new fused model that incorporates turn detection and turn taking alongside the speech recognition. But in general, right, we offer audio intelligence features in addition to Flux, right? So the audio intelligence features we offer do everything from topic extraction, like you said. It can do simple things like summarization, like what did this person say? What are they talking about? It can also determine intent, right? So there could be various intents that we all pre-supply. So common ones are refund, change my address, change my billing information, kind of the table stakes for some of these contact center use cases. But we also do sentiment analysis, which is kind of gives you this kind of positive, neutral, negative, view on how the person is speaking. So if someone comes in, very, very negative, that signal can get fed out directly to a manager. That manager can come in or drop in and say, hey, are you okay?
Real time.
Or it can even, pop up something in front of the customer service rep. So it's like, hey, this person sounds upset. Why don't you work on giving them a discount or giving them a coupon code, trying to make them happy and save them. So really, what Deepgram offers is being able to get kind of early pre-flight intuition about what the conversation is, what's happening on the conversation.
Yeah.
And then from there, you can start to create whole new experiences that weren't even possible, right? Typically, I call into AT&T. I need to update my account. I've got to go through how many steps to actually get to someone,
Yes.
right? And then maybe it can understand my address. Probably not, right? So it's probably better to do online. But if I can do the whole thing with one person or one agent, one voice and one interaction, that's a huge win. So today, for instance, with one of our Fortune 100 pharmacy customers who everyone here knows, we have over 90% call containment with our voice agents doing very complex prescription refills, understanding both medical names, medical diagnoses, and being able to pronounce those and understand those across a variety of English accents, right, and dialects. So.
Yeah. Well, I'm just thinking the information that powers this must be vast, because if we're talking about different cultures and sentiment analysis, different cultures express anger differently, and so I'm just thinking about how much research you have to put into that to be able to grab that. Yeah,
so we produced a white paper about our next gen model, which is called Neuroplex. You can look it up, but what it does, typically with what we call a cascading system, you have your speech in, it converts it to text, right, and then submits it to a model. The model does some magic, right, and then you get this response, and then you feed it back out to speech, right? Mm-hmm. But what you do is you take, the word hello and you convert it to 5 characters every single time, right?
Right.
So all that hello, 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 all that is lost, right? You lose it all because all you end up with is these 5 characters.
Yes.
So our latest model, which is actual true speech to speech, actually lets you pass all that all the way through. So you understand how fast they talk, like what's their pace of intonation. Mm-hmm. What are they actually trying to say, right? How are they intonating what they're saying? What are they emphasizing?
Yeah.
Right? What kind of emotion are they coming in with? Are they hot? Are they, low? Are they, happy, sad, whatever?
Yeah.
And so a lot of that all gets lost today in terms of how the voice agents can function. And so what we're doing is really bringing that back in so that customers can still have that data available to them throughout the context of any sort of voice interaction, and they can use it whenever they like, right? And so not only that, but each step along the way, typically with these cascaded systems, they're all black boxes, right? You get one produces the transcript, one, the model produces the output or whatever question you're asking, and then there's the text to speech to kind of produce these customizable, natural sounding voices. But each of those typically is like a black box, right? You don't know what's going on. And so for customers that really need to understand what the heck's going on, like Neuroplex offers a completely different paradigm where you're able to actually introspect on the intermediate outputs at every single stage. So as soon as you see something's breaking down, you're able to go in and look at what actually happened and figure it out.
Wow. Well, with so much data that you have powering your system, let's talk about latency. Yeah. Because with all of that, it must kind of change the way that you think about how much data to put in, because you think about the trade-offs of like big data, more customization, but then slower response times. How do you balance that?
Yeah, so latency and accuracy are the 2 main things that every customer cares about. Yeah. And so we've spent an inordinate amount of time solving both of those problems, right? And so typically, most vendors are going to make you choose between one or the other, right? You can either have it really fast or you can have it really accurate, but you can't have both. And so in a batch situation where you've got a ton of audio, you can feed it to the Nova 3, our transcription model. Mm-hmm. It could take as much time as it needs to get extremely accurate, right? Yeah. But in a conversational situation, that doesn't work, right? Mm-hmm. And so that's why we've really gone all in on Flux. And Flux allows you to have both without having the compromise of giving up on latency to get accuracy and vice versa. So in general, customers and folks that are building these voice agents typically want the whole round trip to be around 800, 500 milliseconds. That means all the way from the time the user starts speaking all the way through to the time they get a response, right? That's less than a second. That's a very tall order, right? So in order to do that, you have to have ultra low latency on both sides, and then your model has to be already kind of pre-primed, right?
Yeah.
So part of the value of some of the services we offer is that you get the early transcript before the user's done speaking, right? Not only you get the audio intelligence features that we talked about earlier, but with Flux, now you get this eager end of turn transcript. So before the transcript's even finalized, you can already start introspecting on what the user said. Maybe they mentioned a bicycle, maybe they mentioned a specific SKU in your catalog, and you want to pull that up for the customer rep before the customer's even done talking, right? Or maybe they've mentioned a refund, right? And then you start pulling up the coupon codes or whatever you have, right?
Yeah.
And so I think not only do you have to get creative around providing an ultra fast experience, but there's a whole new set of experiences that you can create when you have something like that at your disposal, right? When the LLM can start invoking actions as I mention things, that starts to create a way different set of possibilities in terms of what you can put in front of the user, what you can put in front of the people having the discussion. And I think that changes the game significantly in terms of what's possible with these voice agents.
Yeah. It sounds like you think that maybe even years down the line, it's always going to be an either or. Will there be a world where we can have all of it?
I mean, it's today, right? So flux.deepgram.com, you can play with it right now. You can start using it. You can see how fast the transcript gets produced. It's sub quarter second, and it's night and day in terms of the differences between what's traditionally possible with a batch transcription model and these kind of real-time conversational voice AI models. So I think with a combination between Flux and then Neuroplex, which is going to be coming out next year, these products significantly change the game in the landscape in terms of what's possible. And in my experience, most of where I spend time with customers is actually helping them think, right? Helping them think through what's possible. Because typically they're like, oh, it's like a phone system. I can call, I say something, and then I wait for it to done clicking, and then it comes back to me, right? That's very, very past tense, right? So today, all these sci-fi types of experiences where all the emotion, the intonation, all that gets passed all the way through. So instead of talking to Comcast's horrible IVR system, you're talking to C3PO and R2D2, and they understand exactly who you are, why you called, what you're talking about, and what matters, right? And I think that's the line that we're at right now. We've already crossed that line.
Wow. Okay. I have one last question for
Absolutely,
you. Yeah. So with the rise of generative voice and deepfakes, what role does Deepgram play in ensuring the ethical use and the authenticity of the voice AI?
Yeah, so that's a great question. I think voice spoofing is definitely a huge attack vector now, right? And I'm even worried about my mom getting calls right in my voice saying I'm in jail or whatever the heck, right? So I think there's a lot of movement around this, and I think most of the big LLM providers like ourselves and foundation model providers are taking this really seriously, right? You see what OpenAI is doing with watermarking all their video. Chirp, Google with Chirp is watermarking the same on Veo and some of their other outputs that they make. So we're going to be doing the same thing. I think that's one of the reasons we've waited so long with exposing out voice cloning. I think what 11 Labs has done is pretty irresponsible, in my opinion, letting everyone clone a voice. You could go and get YouTube video of Sam Altman, right? If you get his phone numbers, you can start to, it's really dangerous, honestly.
Yes.
So I think watermarking is probably the first step. And there should be both, audio and container level watermarks. But even those can be kind of, you can get around those, right?
Right.
So I think it's going to be really a whole industry approach. I think it has to be, at the front end or at the beginning, right, with the foundation model creators, so that they're watermarking the outputs. Then it has to flow all the way through to whoever's consuming, so they understand, hey, these watermarks are here, and if they're not there, maybe it's genuine, right?
Yeah.
And I think there's other technology like blockchain and stuff that are designed around kind of shared trust mediums and these ledgers that lets you put something on the blockchain, it has full provenance. You have the history, and you know exactly where something came from, and that that transaction history is all immutable, and you can't fake it, right?
Yeah.
And so I think a lot of this broad adoption will happen, but it's going to be incremental and kind of flowing downward from I think the model providers.
Yeah. It sounds like ethics needs to be a mindset that everybody has from the conception to output.
Yeah, all the way through, right? Like I would love it if AT&T could filter faked voices from ever reaching my parents, but like the reality is they're going to be those things take time.
Right, of course. I'm glad you're working on it.
Yeah.
So thank you so much.
You're
and
very
thank
welcome.
you for your time.
Thanks so much for having me.